Coercion truthiness is something that happens a lot in JavaScript. It's extremely common, and it's something that can be quite devious because people use it, and sometimes it's actually kind of not clear what's happening, but a lot of things are happening. Um, Also, I hear some background noise, so if you just put yourself on mute for now, and if you have a question, just unmute and shout at me. That would probably be better, just to minimize any background noise. Thank you. Okay, great. So we're going to talk about a lot of different things today, but you'll see there's a central theme, kind of in everything we're going to talk about. Okay, so before we talk about coercion and truthiness, the first thing to mention is something around types. So data types in JavaScript it's a principle that we've all seen already, right? We've seen numbers, strings, we've seen booleans, we've also seen functions. And basically in JavaScript, there's about 6 major types, 3 of whom are primitive. Actually, no, sorry. There's, yeah, 3 of whom are, oh, sorry, 6 of them, there are 6 primitive types in JavaScript, and 3 of them we've already seen yesterday in our workshops, right? So there's numbers, strings, and booleans. What makes a data type primitive, or another word to think about it is immutable, is basically once you create a value of a primitive data type, that value can never be changed. And we saw a little bit of this yesterday when we did the crazy caps problem, where the goal was to capitalize every other letter in a string. Um, I think every group eventually got to the point where they realized, oh, so I can't just go into the string and change the 3rd letter, the 5th letter, and the 7th letter, right? I actually need to create a brand new string, and recreate the string from scratch. And the reason for that is a really good demonstration of the immutability of string data types, because essentially what the JavaScript is saying is, hey, you created a string of, let's say all caps. You can never change any of the characters in these never change any of the characters in the string. And so because that data type is immutable, because once you create it, you can never change it, that's what makes it a primitive data type. Similar thing goes for numbers, right? If I say x equals 6, x is a variable and 6 is the number value, the number type, right? I can change what x is because x is just a variable. It just tells me, hey, my value is 3, my value is 7, my value is 100, right? But I can never change 6, right? In JavaScript, 6 is 6, just like in life, right? 6 is 6, 2 is 2, a number is a number. Same thing goes for a Boolean. A true is always true, a false is always false. And then there are a few other primitive data types that you're going to come across. We're not going to talk about too much in this class. Usually when you see them, it probably means something went wrong, quite honestly. And those are the nulls and the undefined. And then lastly, symbols, which we don't cover at all in this class. Right. So for us, the main primitive data types are numbers, strings, and booleans. And the main thing to know about them is that once you create it, you can never change it. You're free to create a brand new variable with a brand new value, but you cannot change the value that you already have. And the contrast, or the flip side of these primitive data types, are what we call the mutable data types, or the complex data types, or the objects. These things are functions, arrays, and objects primarily, and we'll cover all of these later. But if you think about an array, right? If I give you an array of 4 things, I can really easily add a 5th thing to that array. And by doing so, I've actually changed the underlying array, right? That's something that I can't do with a string, right? I can't say, hey, here's a string, let me just add a letter to the end of it. What you're actually doing is, if you remember the workshop from yesterday, what you're actually doing there is you're actually taking one string, you're taking another string, and you're creating a brand new 3rd string out of it when you add those 2 things together. With an array, there's no kind of extra work, right? It's just, here's an array of 4 things, let me add something to the end of the array, and now my array has 5 things. So with arrays, objects, and functions, it means I am able to fundamentally change it. With primitive data types, it means I cannot change it. So this kind of brings us to the first major topic of today, which is around the idea of coercion. Coercion is just a fancy way of saying change type, right? And the one that we'll start with, it's not really a type of coercion, it's just kind of a naming that we do to differentiate it from the next slide. But explicit coercion, as the name indicates, means it's an explicit change of type, or a very clear change of type. So on line 6 here, I've created a variable called num. I set it to give it the value 10. If I console log out type of num, I get back a number. Or sorry, not to ruin it for you guys. On line 7 there, when I do console log type of num, I get number. And type of, by the way, is a very helpful thing, especially when you're first starting off and you might be confused at certain junctures about, hey, what value is this? What variable is this? Type of, if you noticed, it's not camel cased. And usually in JavaScript, you can kind of bet that whenever you see any word that's not camel cased, usually assuming the author isn't making grammar mistakes, that means it's a reserved word, right? And so type of, just like break, just like continue, just like while or for, and a few other kind of things we've seen so far, it's a reserved word in JavaScript, which means if you do type of in your code editor, it will probably show up in a different color, and that's because type of is built into JavaScript, and type of quite simply just gives you the type of whatever value you put after it. Okay, so on line 7, when I do type of num, JavaScript tells you, hey, num represents a number type for now. Okay, on line 9, we create another variable called lowercase string, lowercase string, and we set it equal to. And the right hand side, this is something that I don't want people to get too confused about, but you'll notice we have this capital string, capital S string. And so what that means is we're actually referring to a class. If you remember yesterday I mentioned, hey, when you're naming variables, follow a lot of conventions. They for the most part are pretty straightforward. If you mess up, the computer won't care, humans might. But the one thing you don't want to do is capitalize the first letter of the first word in your variable, because that indicates you're talking about a class. And in this case, every data type we've seen so far, a boolean, a number, and a string, well, those exist in JavaScript, right? Which means someone must have built them into JavaScript, and that means that they also exist as global classes into JavaScript. For the purposes of this session, all I'm going to say is just that if I ever want to create a string, one way to do it is to write, quotation mark, this is a string, and quotation mark. That's totally valid. The other way to do it is actually to pass in whatever value you want to convert to a string into the global class. And so here on line 9 on the right hand side, you see we have the global class string, and we're invoking that global class, and we're passing in num. And all that does is it tells JavaScript, hey, or actually it tells the global string class, hey, whatever I'm going to give you, can you turn it into a string for me? Okay, and so on line 10, when we console log out lowercase string, remember, uppercase string, the global class, lowercase string is just a variable that we created on the left-hand side of line 9. When we console log out string, we see 10 still, but when we console log out type of string, we actually get back not number anymore, but string. And so this is explicit coercion. This just means I gave you a variable of type, in this case, number. I put it into this string class, and the output was a variable that looks like a number, but actually it's a string. And it's explicit because on line 9 there, right, I am kind of almost literally in caps saying, hey, turn this into a string. Cool. And obviously this works in a variety of different ways, right? Remember, explicit coercion, or coercion in general, right? There's no directional sense. It's not like you can only change A to B, right? We can change anything we want to any other data type we want. And we'll see in some cases in which that might not work out well. But in this case here, when we talk about explicit coercion, on line 6, we have this variable called string, and we're setting it equal to a string. Notice how the right hand side of that is not the number 1,000, right? It's literally a string with 4 characters, 1000. Okay, it's not a number, it's a string, and when we console log out type of string, it will say string. On line 9 now, we're doing the same thing as before, except now we're saying, hey, here's a string, can you make it into a number? And the way for us to do that is, once again, take the capital N number, the global number class, and feed in the string there, and say, great, can you make this into a number for me? And the output of num then, if we console log it out and we do type of, so on line 7, when we do type of string, we get, it's a string type. If on line 10 we console log out num, we get back a number. And on line 11, when we console log out type of num, it gives you back a number type. Okay, so explicit coercion just means there on line 9, we're very, very clearly saying, hey, give me back a number of, or sorry, give me back a value of X type. The reason why we make a big deal about that is because, unfortunately, in JavaScript, most times what we see is not this kind of very transparent, very straightforward explicit coercion. What we see is something called implicit coercion. So the coercion part of it is the exact same thing as before, right? We're still changing a value from one type to another type, except now the problem becomes we're actually being a little bit more, I guess, opaque or not as clear about how we're changing it. So let's take a look at an example. And by the way, just as a habit, I don't necessarily talk through every single bullet on a slide. I just try to cover the main ideas. And if you want to go back and look through it, you have all the slides yourself. Usually, I just try to hit upon the main parts to hopefully give you more time for the workshops. Okay, so implicit coercion. So here on line 1, I have a basic math equation. The number's 10 plus the number's 20. I add those up, I get 30. On line 3, I do a concatenated string, right? Basically, I'm trying to add two strings together. And here I have two strings. Notice how those are not the 10 and 20. Those are one string with the characters 1, 0, plus a second string with the character 2, 0. And on line 5 here, I'm trying to do something that, like line 1 makes sense, right? It's just math. Line 3 also makes sense. I'm adding two words together. I get back a super word or a super string. On line 5, if I add a number to a string, what happens? And so, not to ruin the surprise, line 1, I get back my 30. On line 3, I get back a super string or a joint string, I guess, of 4 characters, 1, 0, 2, 0. Not as numbers, but as literally like characters. And then on line 5, when I add in the 10 to the string 20, I get back actually the same thing I got on line 3, which is 1, 0, 2, 0, not as numbers, but as characters. And so the reason for this happening is because this is an example of implicit coercion. Unfortunately, this is one of the few things in JavaScript that you just kind of have to memorize or know. And I say that because most programming actually isn't based that much on memorization. It's much more based on kind of having an understanding of core principles, and you be able to figure out when something goes wrong, why. In this case, this is something you just kind of have to know, unfortunately. And basically, when JavaScript, whenever you're trying to add a number to a string, what JavaScript will do first is it will say, oh, okay, you're trying to add a number to a string. Step 1 is let me convert both things to a string first. And then step 2 is let me add them together. So on line 5, when we do that 10 plus the string 2, 0, what JavaScript does is okay, let me convert both sides of it to a string. So it actually does a coercion of changing that 10 to the string with the characters 1, 0, and then it adds it together, which is why we see this string 1, 0, 2, 0. Okay, and so this is still coercion because at some point behind the scenes we're changing that 10 we're changing the number 10 into a string, but nowhere on this page do we actually see JavaScript explicitly call the string global class. So that's why we call it implicit coercion. And it's also a reason why in some of the workshops from yesterday, if you try to add a string plus a number together, you might have been surprised at the results, right? You might be like, why do I see this extra 0 here, or this extra 6, or this extra 100 here? And the reason for that is simply because when you add a number to a string, JavaScript's doing one extra set of coercion behind the scenes that you're not seeing. Yep. So here's a fun little experiment, right? On line 7, when I add the string 1, 0 plus 20, 30, 40, 50, what do I get? Well, to no surprise, when I add 10 plus 20, I get back 1, 0, 2, 0. When I add it to 30, JavaScript converts the 30 to a string, so then I get 1, 0, 2, 0, 3, 0, etc., etc. And finally, I basically have this massive string of 1, 0, 2, 0, 3, 0, 4, 0, 5, 0. And the type of it is a string, okay? And this hopefully makes sense. Now, if you want to get a bit trickier, what if I give you this? This looks the same as before, except now instead of adding the string at the beginning, we add the string to an end. What do we see here? And the answer is we see this. It's the end result is also a string, but now we see it as 1, 0, 0, 5, 0. So let's talk about where that comes from. One of the things that in JavaScript, one of the things that really helps you when you're being a programmer is thinking through things the way a computer would, right? Like putting yourself in the shoes of a computer and being like, okay, what do I do? I think I mentioned this already yesterday, but computers are really, really, really great at doing highly precise, highly logical things, millions upon millions of times very, very quickly, right? The one thing they're really bad at is ambiguity, right? A computer doesn't know what it means to be like, oh, like, I don't know, like, let me just try this, right? So on line 7 here, if we put ourselves in the shoes of the computer, how does the computer actually see the right-hand side of that equal sign? Well, a computer does an operation one step at a time, right? So to a computer, the first step of that operation is 10 plus 20, right? Because we're going from left to right. So because of that, one of the things that you're going to actually realize what the computer is doing is it's going to say, okay, well, what's 10 plus 20? Well, that's just 30, right? It's just math. There's nothing special about it. I'm just doing basic vanilla math. 10 plus 20 is 30. Okay, what's next? Well, let's add another 30 to it. Well, what's 30 plus 30? That's 60. Okay, let's add another 40 to it. What's 60 plus 40? It gives me 100. Okay, great. And then lastly is let's add the string 50 to it. Well, now I'm trying to add a number plus a string. And so when I do that, what does JavaScript do? It goes back to its old implicit coercion principles, and then it converts both sides, the left-hand side and the right-hand side, to a string. The 100 becomes no longer 100 as a number. It becomes the string 100. They add both of them together, and that's why we end up with our string of 10050. Any questions so far? Everyone's good? Okay, then. Great. All right. So yesterday, someone asked us. I think there was a question around like, oh, so here they use 3 equal signs. I've also seen 2 equal signs. Let's talk about why would we use one versus the other? Is one better than the other? And I guess hopefully that first bullet, that first like 5 words, makes it really clear. In this class, we will always be trying to use triple equal sign and never double equal sign. And the reason why is because I think the person yesterday also kind of mentioned this too, right? Is when we use triple equal sign, like kind of more equality, if you will. That's what we call the kind of explicit, explicitly equal. What that means is for 2 values to be equal under the triple equal sign, they have to both have the same value, but also have the same type. Okay. When we use the double equal sign, what JavaScript is saying is, hey, you want to compare these 2 things. If they're the same type, I'm just going to compare them. Right? It operates the same way as the triple equal sign if the 2 things you're comparing are the same type. However, if the 2 things are different types, implicit coercion is going to say, let me try converting them to the same type first and then comparing them. So it does this extra step for you. And so to us, you might think, oh, wow, like that's helpful, right? Why would we not want that? And so I will show you why we don't want that. So if I do JavaScript double equal, and I'll do MDN, which stands for Mozilla Developer Network. It's a really good reference for it. But if let's see, should be this link here. If you go to this link, this will actually, this explains kind of what JavaScript is. If you scroll down far enough, you'll see this, let me just zoom out a little bit. You'll see this little intimidating table here. And what this table is actually saying is, hey, when you're trying to, let me make sure, yep, loose equality using double equal sign. If you do this, what this is actually saying is, hey, if I'm comparing A to B, and A is a string and B is a Boolean, I'm actually going to convert both of them to a number first, and then use triple equal sign. Right? In fact, if you notice all these tables, all they're doing is they're converting, for example, in this case, if A is a number and B is a string, I'm comparing A and I'm converting B to a number first and then using the triple equal sign. And so, and if you notice, this table isn't exactly parallel. It's not exactly straightforward. Depending on what the type is, it does some pretty crazy things. And so unless you're someone who kind of wants to memorize this table and know at all times what A and B is, double equal sign can get you in trouble very quickly because sometimes JavaScript does something that's very kind of unpredictable. And so because of that, double equal sign oftentimes just causes a lot more risk because there's a lot more unknowns. Like if I'm feeding in a Boolean to an object, I get this monstrosity, right? In fact, this takes it to a double equal sign, which means I need to do another variation of a number to a primitive, right? And so it just gets very, very hairy very quickly. And so whereas a double equal sign could potentially leave some more room for ambiguity, oh, sorry. So whereas a double equal sign could leave more room for ambiguity, a triple, oh wow, sorry, a triple equal sign just says, hey, they have to be of the same type and of the same value, and therefore, it's just a lot more clear and transparent what you're comparing. If you need to ever compare a number to a string and you want to make sure, hey, if I convert them both to a string and I'll make sure they're equal, well, guess what? Just use triple equal sign and do an explicit coercion where you convert the number to a string. That way, if another human being is reading your code, they'll be like, oh, okay, I see what David's trying to do here. He's taking this number, he's explicitly coercing it to a string, and then he's comparing them to make sure that A, they're both strings, and two, they both have the same value, right? Logically, that does the same exact thing, except now to the reader, it's super clear what's happening. Okay, so here's just a few examples of when we use double equals, why it sometimes gets you in trouble, right? Line 4, 10 equals 10, yeah, that makes sense. The number 10 equals the string 10, makes sense. The string, true, does that equal true? No. Does an empty string equal false? That does. And so you just kind of get a sense of the universe of these values in which when you use double equal, things might not turn out the way that you think it does. Okay, so the short of this is in your code, always use triple equal signs. There might be a very, very small use case in the far future in which you need to use double equal signs, and you can address when you get there. For everything that we do, triple equal signs is by far the more preferred option. Okay. So we've talked about coercing things into numbers and strings primarily. But actually in JavaScript, by far the more common way of coercion that we do has to do with coercions into booleans. Remember, booleans are a type with only two possible values, true or false, right? In computer speak, even easier, 1 or 0. 1 is true, 0 is false, right? And computers are all just processing ones and zeros at the end of the day, which is also why they're bad with ambiguity, because we only have two possible choices, right? You either choose one or the other. Any value can be coerced into another type. Sometimes you're just not quite clear on what the type you get is, right? And so with a Boolean, when you're trying to convert any value to a Boolean, it's also a little bit, it's actually a little bit of like a boon, because it actually is a lot more straightforward than some of the other data types. Whenever you're converting a value to a Boolean, all JavaScript is saying is, hey, is this a value that becomes true or a value that becomes false? And so any value that when you convert it to a Boolean, it becomes true, it's known as truthy, or the very scientifically precise term, right? It basically means truth-like. Similarly, if I have a value and when I convert it to a Boolean, it becomes false, then I call that value a falsy value. And so in JavaScript, it's actually a lot easier for you to figure out what's falsy, because everything else that's not falsy is truthy. Because once again, that's the value of dealing with A or B, right? If it's not B, it's got to be A. There's no other possibility. And so I see over the previous slide, because I think it's actually a lot easier for us to talk about what's falsy first, right? The only values in JavaScript that are falsy or that becomes false when you convert it to a Boolean are the empty string, the number 0, nulls, undefined, this NaN, which stands for not a number. We won't see that just yet, but if it does come up in your code, let me know and I kind of walk you through why that is. And obviously, of course, false itself, right? So if you have a value that's an empty string, a 0, null, undefined, not a number, or false, when I convert to a Boolean, I will get back false. For every other possible value in JavaScript, when I convert to a Boolean, it will give me true. So if I just rewind a little bit to the previous slide here, I am a string, the number 10, an array, an object, any of these are all truthy when I convert it into a Boolean. These are all true when I convert to a Boolean. These are the only false values that I get when I convert to a Boolean. The only one we didn't list on here is obviously false itself, right? The Boolean false value, if I convert to a Boolean, by definition, it also equals false. So that's how Boolean coercion is saying, hey, every JavaScript value can be put into the bucket of either truthy, which means when I convert to a Boolean, it's true, or falsy, which means it converts into a false when I convert into a Boolean. Any questions so far before I move on to conditionals? The silence is both good and also a little bit scary too. Um, okay. Conditionals. Remember we saw this yesterday in our while loop, in our for loop, and a few other kind of crevices too. Well, a conditional actually, by definition, if you remember yesterday, we had these things where we are like, oh, is count as less than or equal to 3, right? If I give you that, you're like, well, yeah, that's either true or false, right? I'm doing a statement. But what makes conditionals very kind of interesting is conditionals basically force, right? What they're doing behind the scenes is they're actually coercing whatever it is you put in there into a boolean. So if what you give them turns to a boolean, that's totally good, right? And JavaScript says, great, I get back my true or false value. If what you give them isn't a boolean, well, they just kind of implicit behind the scenes, they convert into a boolean for you, and depending on whether the boolean is true or false, it determines how it proceeds with the loop. So here in this if statement on line 4 there, right? My conditional is basically what's in the parentheses. Well, here I'm just passing the number 5. And so upon first pass, JavaScript says, okay, well, it's not a true or a false. You gave me a 5. So should I do the if block or no? Well, all it does is says, great, let me convert whatever you gave me into a boolean. Is 5 a truthy value or a falsy value? Well, 5 is a number and it's not 0, so therefore by definition it has to be true. And so when we do this, we console log out in the if. Similarly, if I pass in a string apples, well, once again, JavaScript says, okay, you gave me a string. I just need to know if this is a true or false, right? So I'm just going to convert it to a boolean. Is this string true or false? Well, it's not an empty string, so by definition, it's going to be true. Oh, sorry. Right? So it's a truthy value, so it's true. And so when I console log out, when I run this code, it also console logs out in the if. The short of this is just to say that JavaScript will whenever you see the word conditional, all it means is that it's not just like a suggestion, like, hey, it'd be really nice if you gave me a true or a false. JavaScript will mandate that eventually if you don't give them a true or false, they will try to change it on your behalf into a boolean, into a true or a false value. So on line 3 there, we see the 10, which is truthy. On line 10 there, we see the 0, which is falsy. And so therefore, when I run this code, the first one will console log out a yes, and the second one console logs out a no, right? And so all of these are coercion in action, except now we never see the capital B Boolean class being used, but behind the scenes, that's exactly what JavaScript is doing. JavaScript is on your behalf converting whatever it is you gave it into a Boolean, and then in this case making a decision of do I go to the if or the else block because of it. Two other things to notice: the exclamation mark operator. In programming, we call that the bang operator, B-A-N-G. But you can also heard of it. You can also hear it called as a not operator. And basically, when you put the exclamation mark in front of anything, it basically just turns it to the opposite thing, right? So bang true says what's the opposite of true? It's false. What's bang? ABC. Well, ABC is a string, and that's true. So when I convert the opposite of it, I get back a false. And I guess, sorry, one thing I kind of wasn't clear when I just explained it 10 seconds ago is that the bang operator will always return a true or a false. Right. So the bang operator does do a Boolean coercion on your behalf. All it does is it takes the value that comes after it, coerces it into a Boolean, and gives you the opposite of it. So on line 6 there, it takes that string ABC, coerces it into a Boolean, which is true, and then gives you the opposite of it, which is false. And in fact, all the things here, these are all truthy values. So when I convert them to a Boolean, they're all true. And when I put a bang operator in front of it, it gives me back the opposite, which is false. Okay, sorry. So it gives you all false for everything. Okay. The flip side of that would be the double bang operator. So we put 2 exclamation marks in front of something. And the logic behind this, if you try to reason it out, it can be a bit painful. So the way I always think about it is whenever you see 2 exclamation marks or double bang, that's just the exact same thing as converting something to a Boolean as is. Okay, because one bang converts it to the opposite of the Boolean, and then 2 bangs converts it to the opposite of the Boolean. Well, the 2 opposites kind of cancel out, and so a double bang is the exact same thing as converting something to a Boolean, right? So on line 8, for example, if I want to convert 100 to a Boolean, do I get true or false? I get back true, and so double bang of 100 is just same as giving back true. So you'll see this quite a bit in a lot of loops and conditionals, especially that the exclamation mark, all it does is gives you the opposite Boolean form of whatever is value that you're tying it to. Okay, last two things here: logical operators. Logical operators are things that that actually help you check, in some ways, multiple things at once. So the first one we'll talk about is the AND operator. The AND operator is made up of two ampersands. So on your keyboard, that's the number 7 symbol. And what the AND operator does is AND just basically says, I need to make sure A and B are both truthy. And if they're both truthy, then I'll tell you this is true, right? So the way I think about AND is kind of like if I go to the grocery store if I want to bake a cake, right, and I go to the grocery store to buy ingredients. If I need milk and eggs and sugar, well, if I come back with just 2 out of 3, well, it's not good enough, right? I can't bake my cake. And so AND basically says, hey, whatever it is you put here, I need everything in this list. And so on line 3 there, if I do 10 and 20, that basically means the AND operator is saying, hey, whatever's to my left has to be truthy, and whatever's to my right has to be truthy. And so is 10 truthy? Yes. Is 20 truthy? Yes. And so therefore the console log prints out both 10 and 20 are truthy values because it goes into the if block. If, however, I do something like 10 and 0, the AND operator says, great, is whatever's to my left truthy? Yeah, it's 10, great. Is whatever's to my right truthy? Is 0? No, it's not. And so therefore, when I run this code, nothing in the if block runs because the else block runs because on line 3 there, that conditional, that 10 and 0, it's going to give me back false. It's saying, hey, not everything in this list you gave me is truthy. And so one of the really kind of cool principles about the AND operator is we can actually chain it together, right? So if I look at line 4 there, I'm actually checking not just 2 things, I'm actually checking 4 things, right? I'm checking 10 and apples and 0 and null. So if I put myself once again in the shoes of a computer and I say, great, how do we actually think through that? Well, I start with 10. Is 10 truthy? Yep, it is. Great. I go to the next one. Is apples truthy? The string apples. Yeah, it's a non-empty string, therefore it's definitely truthy. Great. I go to the third thing, 0. Is 0 truthy? And the answer is no, 0 is falsy. And so if I'm the AND operator, I actually stop right there. There's no point in me checking the fourth thing, the null, because regardless of whether that's truthy or falsy, it doesn't matter to me, right? If I need everything in this list to be truthy and I come across the first false, I'm done. I can just say, hey, there's no way this list is going to satisfy my requirements, right? And so what the AND operator does at that point is it just returns the first false value it sees, or in some cases, in other cases, if it does make it through to the end of the list, like it does in line 7 there, if I check the string lucky, which is truthy, and then the number, which is the string number, which is truthy, and then the number 7, which is truthy, if it gets to the very end of the list and it says, great, I'm at the end of the list, everything is truthy, this is all truthy, then it returns 7, or the last value, right? And so based on what the AND operator returns, if it returns a truthy value, then it means, hey, it made it all the way to the end of the list, and this is the last truthy value, so therefore, if you convert to Boolean, it's true. On the other hand, if it returns back a falsy value, it means, hey, at some point in this chain of things, it came across a falsy value, and it gives you back the first falsy value it finds, and it stops right there, right? Because there's no point in checking the rest of the list if I know that I already have at least one falsy value. So that's what the AND operator does. And then the cousin to the AND operator is what we call the OR operator. It's made up of 2 vertical lines. Those symbols are called pipes. On your keyboard, they're probably right underneath the backspace key. So what the OR operator does is now instead of saying, like if I say, hey, I need a car and I need, a Honda or a Toyota or a Ford, right? I don't need all 3 cars. I just need one of those things to be truthy, or I just need one of those things. That's what the OR operator checks for. It just checks a list of things and says, hey, are any of these truthy, right? So if I go look at line 4 now, saying, is null truthy? No, it's not. Okay, so what's the next one? Undefined. Is that truthy? No, it's not. What's the next one? It's the string happy. Is that truthy? Yeah, it is. And at that point, the OR operator just stops and says, hey, I found your first truthy value. And once again, there's no need to check the fourth value, right? Because if I needed just at least one truthy value, well, I have one, right? Regardless of what the fourth thing is, it's not going to change my answer because I found at least one. So I can just kind of, so the OR operator just stops at that point. Similarly, if I have a string of all false things like I do on line 7, it will return back the last falsy value, the last falsy value. And so depending on what the OR returns, it will also tell you if it made to the end of the list. If it does, it will give you back a false. If it gives you back a truthy value, then it means somewhere in that list it came across a truthy value. And that's pretty much it. So everything in this session has to do with kind of coercion and changing between one type to another type. But you know, a lot of it I know can also seem like a bit disjointed in terms of like, well, there's bang operators, there's and or, and a bunch of different things. But these are all things that you will definitely see as a programmer. And so you kind of need to be aware of these. These are not tools that you can just avoid, like some of the other things we'll talk about in later sessions. So on that note, are there any questions before we get started on the workshop? Did we also lose 2 participants during that lecture? Hopefully it wasn't that bad. Any questions at all before we move on to the workshop?
I think that for a lot of people, I mean, at least having the slides overnight the night before definitely had some time to process everything. Plus, a lot of people are probably really familiar with this as well, so it's not a bad thing.
Great, awesome, that's great to hear. And just yeah, and that's actually a really good point. When I opened the pre-work, I think they give you a video, but I think they also give you the slides beforehand too, right? So you guys were able to access this last night. I know last night, as in like after 8 hours of programming, I gave you like 3 more decks to 3 more set of slides to read through. So maybe timing wise, it wasn't the best, but yeah, you guys do have access to this usually the night before. And actually for the following week, I'll just open up all the sections for next week. So if you want to get a head start, you could. Yeah, so remember how yesterday when we did loops and people were like, oh, this is pretty easy and pretty straightforward, and then we did a workshop and it was like a little bit painful. That's also probably what's going to happen today as well. And so rather than me talking more about it, let's just get you out there doing it. So let me stop the recording here.